Good day and welcome back. Okay, so we're looking at assignment 2 here, and we continue to review the questions. So the next group of questions are on annuities. So this section will be dealing with annuities. And annuities are really payments that are made in a stream, so a series of payments that are made over a course of time. And the question that we're really looking at in these type of things is how does this annuity flow? How does it flow, and what is the value of it at a certain date, either at the end or at the beginning? So our first question deals with Mr. Finley. So Mr. Finley just turned 40. Okay, so he's 40 years old. And he has already accumulated $24,500 in an RRSP. Okay, so he's going to make monthly contributions of $300 to this. So he's going to make a contribution right up until he's 60. So that's $300 per month. And he's going to do it until he's 60. At that point, he's going to stop making contributions. Okay, so that's clear. The RRSP will be allowed to grow from 60 to 65. So again, 60, 65, we got growth. There's no contributions, it's just growing. And the RSP earns 10% compounded monthly. And so effectively, what we've got here is a problem that we're being asked, what amount will his RSP contain when he reaches 65? So we want to know the value at this point in right time. So we're looking for future value here. We always need to consider where are the values we're looking for. So what we got to do is bring everything ahead to this point right here. So this 65 is our focal point. Okay. Now, there's a number of things. We got to break this problem down into parts. We got a fixed amount here. We got a fixed amount, and we need to figure out what that fixed amount is going to be at age 65. I'm going to call this step 1. Okay? The other thing that we have here is a stream of funds . The other thing that we have is a stream of funds that goes from 40 to 60, 20 years worth of funds. And we got to find out what the value of that is. Now, this is going to end here. So first we got to find the value here. Okay, so we're going to find the value at the 60 point. And then we got to take that and we're going to find the value of that amount right here. So this is going to be the value at 65. So really we got to be able to do a third step, and this is called step 3, where we're going to take the value at 60 and find out what the value of that is at 65. Okay, so let's proceed to look at the various steps, and I'll just put this aside here. Okay, step 1. Step 1, we're going to take that $24,500 and we're going to project it ahead 25 years. So he's 40 now to 65. Okay, we're going to project it ahead to 25 years, and we want to find out what the future value of that money is. Okay, so that's what we need to do first. That's our very first thing that we need to come up with. So we've got the present value is $24,500. We've got the 10% return rate, and it's a monthly contribution, or a monthly compounding, I should say. So that's 10% divided by 12, and that's 0.83% per month, which is 0.0083. So that's the value of I. So that we know the value of I in that case. We need that for our formula. And we also know that if it's monthly, 25 years times 12 per month is 300 compounds. So the value of n is 300. So let's just plug that into the formula. So we're looking for the future value again. We want to take that number up to here. So future value is the present value 1 plus I to the n. So we're taking 24,500 and it's 1.0083 to the 300. Okay, so that's the calculation there. And if we do the math on that, we do the calculation on that, that'll come up to 295,365.86. So effectively, that amount earning 10% for 25 years will be that. So that's the value at age 65 of the 24,500. Okay, so that's what I would suggest you is step 1. Now, just bringing back our sheet here, we want to find step 2. Step 2 is we're worried about this stream. So there's a stream of payment that goes for 20 years. Okay, so we're going to look at that stream. Okay, let's look at the step 2, the stream. The stream runs from 40 to 60, so that's 20 years. It is $300 that is put in, and that's put in per month. So let's just think about this in terms of months. Now it's 20 times 12. That's 240 months. That's something we need to consider. The other thing is that it's a 10% interest rate, and again, like we've seen, it's monthly, so 10 divided by 12, so that's 0.0083 is the value of I. So the 240 months is the value of N. What else do we need here? Yeah, well, that should be good. All right, so this is a stream, so we need to be able to calculate what is the future value. We're looking for the future value here, so let's take the future value of the stream. So future value is the payment. 1 plus I to the n minus 1 over I. And we know that the compounding and the payment are month and month, so this is an ordinary simple annuity. Compounds and payments are the same, so we just use this formula. We don't need to calculate an I2. So the payment again is 300, 1.0083. We calculate N to be 240 minus 1 over 0.0083. And that comes to 227,810.65. So here's the value of the stream at age 60. So value of stream at 60 or at the 20-year mark. Okay, so that's the stream. Now, let's go back to our original sheet again. The third stage of this problem is taking this amount that we just calculated and bringing it ahead 5 years to bring it to 65. Okay, so we got, that's just sitting there, so we're looking for the future value of that amount in 5 more years. So let's take this step 3 here. Step 3, we're taking the amount of 227,810.65 that we've calculated here, and we're bringing it ahead 5 years to the 65 mark. Okay, so what we are looking for there is a future value. So let's just plug the numbers in on that. We've got 5 years, the number of compounds, 12 compounds per year is 60, so N is 60, and we know I is 0.0083, and that's repeating, but I'll just round it for here. So the formula then is the future value is the present value 1 plus I to the N. So we take we figured our value is 227,810.65 times 1.0083 to the 60. And so if we do this, that's 374,818.89. Okay, and so let's just go back to our original here. And I'm going to check the math on that now. I'm going to check the math on that calculation just before I go any further. Whoops. That was not right. Okay, forget it. Okay, so let's look at this then. We've got a couple of things here, and so let's bring to our conclusion here. So the conclusion is, well, at age 65, okay, so at age 65, the stream plus the future value amount, so this is step 2 and 3, is worth 374,818.89. And step 1 was the 24,500 that grew and grew and grew. And that grew to 295,365.86. If we add those two amounts together, that comes to 670,184.75. So in conclusion, at age 65, he will have $670,184.75. That's that one. Okay, the next annuity problem we have here is Q2B. And it says that determine the present value of $5,000 paid at the end of each calendar quarter for 6.5 years using a discount rate of 8% compounded quarterly. So we got $5,000 paid at end of quarter. 6.5 years, 8% compounded quarterly. Okay, so this is an ordinary simple annuity. The reason is that the payments are quarterly and the compounds are quarterly. OSA. Okay, that's the first thing you need to be able to identify. So let's take a look at what we need to do in this problem then in order to be able to resolve it. Okay, so we have to figure out our value of I first. Well, it's 8% compounded quarterly, so we need to divide it by 4, and that will give 2% per quarter, which is 0.02. Okay, so that's the value of I. The value of N, well, there's 4 quarters per year times 6.5 years. So 4 times 6.5 is 26. So what we need to be able to do is to calculate the, it's really asking us what is the value. Okay, so we go back and we look at it and we say, what is the value here, the present value? So we're looking for PV, the present value of that stream of money. So we know that our present value formula of a stream is the payment, 1 minus 1 plus I to the minus N over I. Now, as I say, it's an ordinary simple annuity because our quarterly payment and quarterly compound. We just simply plug the numbers in, and so the payment is 5,000, 1 minus 1.02 to the minus 26 over 0.02. If we do the calculation on that, that will come to $100,605.18. So effectively, the present value of that stream of payments is $100,605.18. That's the second one. Okay, have a look at that. Let's move on to the third question. Q3B says, how much will it cost to purchase a 2-level retirement annuity that will pay $3,000 at the end of each month for the first 15 years and $2,000 per month for the next 10 years? Assume the payments represent a rate of return of an annuitant, the person receiving the payment, of 6% compounded monthly. So what we got here is really a two-part problem. How much will it cost to purchase a 2-level? So the very fact that we're looking to purchase it, we're looking really for the present value of the annuity. Okay, we got to purchase it now, so we're looking for that present value. So we got a couple of streams here. We got $3,000 at the end of each month for the first 15 years. Okay, so 15 years, and it's $3,000 per month at the end of month. That's important because it's not an annuity due if it's at the end of the month. It's typical. So that's for 15 years, and then it has to pay for the next 10 years. So there's another one for 10 years of $2,000 per month for the next 10 years. And again, the rate of interest here is 6% compounded monthly. Okay, a couple of things you need to consider here. Are the compounds and the payments the same? And the answer is yes. The compounding is monthly, the payment is monthly. So both of these are ordinary simple annuities. Okay? Now, so we're going to break this into 2 steps. Okay? The first step, and step 1, and step 2. So essentially what we're going to do is we're going to do this in such a way that we're calculating the present value first of step 1. So here you got a stream of payments, and we want to find out what the value of that stream is today. Okay, so let's do that. So this is step 1 of the problem. PV of $3,000 a month, 15-year stream. Okay, that's the first thing we're going to do. Okay, let's plug that into the formula. So it's we have got we've got I. I'm going to calculate that, and again it's 6% compounded monthly. So that's 6 divided by 12, which is 0.5, which that's 0.5%, which is 0.005. Okay, that's the decimal. We also have to worry about how many of these compounds do we have. It's a monthly compounding for 15 years. 15 years times 12 per year. 15 times 12 is 180. Okay, so we have got I is 0.005, N is 180, and the payment is 3,000. So let's calculate the present value of that. PV equals PMT 1 minus 1 plus I to the minus N over I, and that payment is 3,000. 1 minus 1.005 to the minus 180 over 0.005, and that will come to 355,510.54. So effectively, this stream right here, stream A, is worth 355,510.54 on that date. Okay, so that's stage one. Now we go to step two. Now step two is really two parts, so it's part A. What we need to do in part A is we need to look at this stream, and we need to bring it back to the present value at the beginning of the stream. So we're going to take this stream and we're going to bring it back to here. So it's 10 years of stream, and we're finding the present value of it here. Then we got to take that and bring it back to here. So this is what we call part B, and that's really a value that we're bringing back 15 years to a present value. So that's just a fixed amount that we're bringing back to get the present value of. Okay, so in part A, and again, the information is the same in terms of the value of I. It's the 6 over 12 is 0.005, so it's the same. N is 10 years times 12 per year. N is 120 in this case. Okay, so let's just plug that in. PV equals the payment. And the payment in this case is 2,000. 1 minus 1.005 to the minus 120 over 1.00005. I gotta make sure I get the right number of zeros. So 200. So the present value, we can do the calculation on that, and the present value will come to 180,146.91. Okay, what does that mean? That means that value, that 180,000, is the value of this second stream at the beginning of that second stream. Now what we got to do is part B. Is we need to take that stream and bring it back to now. Okay, so we're going to bring that back. So we're looking for the present value of, we need to take the present value of that stream amount, of the present value of stream to now. So in order to do that, we've got to use the present value formula. This is the fixed amount. The present value is the fixed value. 1 plus I to the minus N. So the future value is 180,146.91. This amount right here. Okay. Times 1.005 to the minus N. Now, what is minus N? I should have done that. Well, what do we got? 15 years, and it is 12 per year. That's minus 180. Okay, 15 years is we're bringing it back. There's 12 per year, so that's 180. So we can calculate the present value of that to be 73,406.70. Okay. Now your numbers might vary a bit because of rounding, but the fact of the matter is that this comes back. So that then is the value of that brought back to there, 73,406.70. So we've got two separate streams now, step 1 stream and step 2 stream. The value of step 1 stream is 355,510.54. The value of the step 2 stream is 73,406. So the total will give us the present value of this whole thing, how much money he needs to put in or how much is worth. And if we did that together, then that should be $428,917.24. So effectively, that's how much that annuity is worth right now. Okay, those couple of annuities really are worth it right now. Okay, so just take a quick look at that. So Q4B. So Q4B says the Atlantic Lottery Corporation's run set for life lottery. The winner of the grand prize can choose either $1 million per year for 25 years. So option 1 is $1 million per year for 25 years. Or option 2, which is a $17 million upfront payment. Okay? Which option should you choose if the payments are made at the beginning of each year? So the payment is at beginning of year payments. Now, what we mean by beginning of year, it is an ordinary, it's an annuity due. It's an annuity due. So I'm going to solve this problem now as stated. And some of you may have had this problem where it wasn't an annuity due, and that's fine. It's just the mechanics of it are identical. Okay, so let's just be careful here to be clear that I'm doing it for an annuity due. Okay, so we ask ourselves, you know, what we're asking ourselves is what is the present value of that stream in option 1, and what is the present value of the amount in option 2. Now I will tell you that option 2 is straightforward. It's $17 million now. That is the present value of it. So we don't really need to do any work with this one. This is the only one we're going to do work with is option 1. Okay? So option 1, let's do the present value analysis of option 1. So we got a stream of payment. Let's just look at the numbers here. So option 1, so the payment is $1 million per year. The interest rate that we're looking at is 5% per year. So the payment is annual and the compounding is annual, so it's an ordinary simple annuity due. It's at the beginning of the year, so it's an ordinary. So BOY, beginning of year, which is an annuity due. Okay. So let's just do this then. So in the first case, we got to calculate our value of I. Okay. Let's look at our value of I. Well, 5% divided by year is 0.05 equals I. So that's the value of I. And N is, well, it's 25 years. And it's 1 per year, so that is 25 is the value of N. So let's put this. So we're looking for the present value equals the payment 1 minus 1 plus I to the minus N over I. Now, seeing this is an annuity, we just multiply by 1 plus I. So that's the distinction between an annuity and an annuity due. We'll plug the numbers in here. The numbers are $1 million. I won't put all the zeros down. 1 minus 1.05 to the minus 25 over 0.05 times 1.05. Okay? So if we look at this, we solve this one first. So for you folks who have done this problem without an annuity due, here is this part. This would be the answer if it's not an annuity due. So we just run the numbers on that, and that comes to 14,093,944.57. Okay, so that's that first part. That's what comes there. And if we multiply, if we do the annuity due is the 14,093. 14,093. $944 57 times 1.05. So the annuity due will equal 14,798,641.85. Okay, so you know, there's the two distinctions based on if it's annuity. This is an annuity, and this is an annuity due. Okay. Regardless, what we're being asked here is what option should you choose? Okay, so let's think about it. You can get $70 million now, or you can get $14 million now. What one are you going to choose? You should select option 2, which is the $17 million now. You're going to pick the higher option. So this is how you calculate this problem, by simply doing the calculation on it and then comparing, is that higher than 70 million or not? So there you go. Thanks for watching.